I also wanted to talk about what does an equation look like if I'm trying to graph it in 2 dimensions when it's missing one of the variables. And basically, those are still called linear equations. They just are kind of specialized cases of those. So let's first talk about what about when x is equal to 4. And really, if you're thinking about an equation x is equal to 4, you don't really need a 2-dimensional graph to graph it because, well, x is just 4. It's a singular answer. So if I was to look at that on a number line, well, x is 4, you know, it's right there. It's going to be 4 left to 0. You would usually just graph it with a point. The thing is, if I switch it to a 2-dimensional graph, I mean, it really doesn't change. And this is kind of what I wanted to get at. What happens if I graph it on an x-y axis and x is just 4? What the heck does y mean? But basically what happens is it will turn into a vertical line because what it's saying is x is 4 and y, we have no information. And that kind of implies, well, y could be anything because it would still satisfy this particular equation. So really you take that point and you'd extend it to a vertical line because notice that all of these other points along the line will also make sense. So let's just say I was thinking about 4, 2 or 4, 0 or whatever. If I were to plug it into the equation, it makes sense because 4 would just go in there. 4 is equal to 4 and 2, it's basically, it doesn't matter. That's kind of the deal with a vertical line, is y could be anything. And sort of the same thing applies towards a when y is equal to -3, which formulates a horizontal line. Because if I think about, again, on an xy graph, this would be, you know, the y-axis is vertical versus horizontal for x. If we were to count out, well, where is y -3? That's down 3. It would be right here. And again, we have no information about x, meaning that any value of x would be fine within this equation since it doesn't exist. So x could be anything. And what happens is we formulate a horizontal line because whatever the point value is for x, it does not matter because notice every one of these points would have a y value of -3. And again, those are totally fine within the equation. So summary here, and notice there's kind of a backwards nature between x-intercept being y is equal 0 and vice versa. Same thing for horizontal and vertical line. X equal 4 makes a vertical line, not a horizontal line as it might seem. Because the x-axis, and I think the reason why this is confusing is because the x-axis is horizontal, which is true, but when x is a specific value, that's along the x-axis, which is what causes a vertical line. And the same is true for y. The y-axis is vertical, but if we specify a specific value on the y-axis, it formulates a horizontal line for exactly the same reason. And again, if you're making a table of value for these, notice that actually these are the only type of lines that are missing an intercept. X equal 4 has an x-intercept but will not have a y-intercept because y can't be 0 in this equation. Sorry, x can't be 0, I mean. Of course y could be 0 as it is in this point, but since x is 4, x can't be 0. And same thing for the horizontal line. Y is always equal to -3, but y cannot be 0. Therefore, there is no x-intercept when we're dealing with a horizontal line.